Today we will see some of the trigonometric identities. As you know, all the trigonometric ratios are related with the ratios of the sides of a right angle triangle. So we have few identities that we will see today. The first one which I will discuss is the reciprocal identities. The sine theta can be written as 1 by cosec theta. Cos theta can be written as 1 by sec theta. Tan theta can be written as 1 by cot theta, and reverse also. Cosec theta can be written as 1 by sine, sec can be written as 1 by cos, and so on. Why this is so? Because I have told you the formulas. This thing I have discussed already. The sine theta is opposite side divided by hypotenuse, cos theta is adjacent side divided by hypotenuse, and tan theta is how much? Opposite side divided by adjacent side. And you know this one, the first ratio gives you the sine, but the cosec is reciprocal of that, h by o. That's why you can write sine theta as 1 by cosec theta, and same way you can write cosec as well as 1 by sine theta. So these are the reciprocal identities. Now let's discuss the second one. The second one is quotient identity. Here the tan theta can be written as sine theta by cos theta, and cot theta can be written as cos theta by sine theta. So again we will look at that formula. So for sine, you know the formula for sine is opposite side divided by hypotenuse. For cos, what is the formula? For cos it is adjacent side divided by hypotenuse, and for tan it is opposite side divided by adjacent side. So you know that sine theta is opposite side divided by hypotenuse, whereas the cos theta is adjacent side divided by hypotenuse. So it will cancel out this thing. So you will get O by A. That is the formula for tan theta. Okay. And you know that tan theta is reciprocal of cot theta. That's why cot theta can be written as cos theta divided by sine theta. Now we will discuss some Pythagorean identities. So Pythagorean identities, basically the name came because we will use Pythagoras theorem to prove these identities. Suppose you have this right angle triangle, and this is 90 degree, and this theta we are taking. So here these three you have to memorize. So these are very important. The first one is sine square theta plus cos square theta equals to 1. Second one is 1 plus tan square theta equals to sec square theta. And the third one is 1 plus cot square theta equals to cosec square theta. So let's first prove our first one. So the first one is sine square theta plus cos square theta equals to 1. So this is our first Pythagorean identity. So suppose we have this triangle ABC. Now what will be the value of sine theta? So from here the sine theta will be AB divided by AC. So I'm just writing the value AB divided by AC. Now we have square of sine theta, so we will write it as AB by AC whole square. Now the next one, we have cos square. So what is the value of cos theta? Cos theta is adjacent side divided by the hypotenuse, so that will be BC divided by AC. And now we have the square also, so we will do the square. So now what we have, we will get AB square divided by AC square plus BC square divided by AC square. This one. Now you know that AB square plus BC square is equals to AC square by the Pythagoras theorem. So it will be AC square by AC square, that will be equals to 1. So this way we can prove our first identity. Second one, I'm taking the same identity that we have proved earlier. Now I'm dividing the whole equation with cos theta. So let's see what we will get. So here in the first time we will get, first term will be sine square theta by cos square theta. Second term will be cos square theta divided by cos square theta equals to 1 by cos square theta. So let's see what we will get. The first one will become 10, sine by cos I discussed. This will be 10, so it will be 10 square theta, plus this one will be 1, and the other one here, this will be 1 by cos sec square theta. So we got the second. So this is your second identity, that is tan square theta plus 1 equals to sec square theta. Now we will prove the third. For proving the third one, I am again taking the first equation, first identity. So here it was sine square plus cos square theta equals to 1. Again I am dividing it. Previously I divided with the sine cos theta. Now I am dividing it with sine theta. So let's see what we will get. So it will be sine square theta divided by sine square theta. So that will be 1. Then cos square theta divided by sine square theta, that will become cot, and 1 by sine square theta will become cosec square theta. So you'll get 1 plus cot square theta equals to cosec square theta. So that is our third identity. So we have proved all the three identities. These three identities are very important. Now we have learned all the identities. Now this is the table where I am showing that all the trigonometric ratios can be written as the other trigonometric ratios. Here I have taken, like you can see, the first one, sine theta. So sine theta in terms of sine is sine theta only. Now you can write sine theta in terms of cos theta as well. So that will be root over 1 minus cos square theta. Okay. You know the identity sine square theta plus cos square theta equals to 1. So from there you will get this value. The same way you can get the tan theta. So tan theta, sine theta in terms of tan theta can be written as tan theta divided by 1 plus tan square theta. And the same. Now I will tell you a short method to find out all these. So here we have sine theta equals to opposite side divided by hypotenuse. So what I am going to write here, I am writing my opposite side as sine theta, okay, and hypotenuse I am taking as 1, and just comparing these two. So from here opposite side I am taking as the sine theta. So this is the opposite side. So I have written this as sine theta, and the hypotenuse I have written as 1. So now you can use the Pythagoras theorem. So if you use the Pythagoras theorem, then the third side will be how much? 1 minus sine square theta. Okay, you know that sine square theta plus bc square is equals to 1. Okay, so from here bc square will be how much? 1 minus sine square theta, or bc will be 1 minus root over 1 minus sine square theta. Now you know all the trigonometric formula for the trigonometric ratios, that is cos theta. So cos theta is how much? Adjacent side divided by hypotenuse. So you can write from this figure all these sides we have already. So adjacent side is root over 1 minus sine square theta divided by hypotenuse is 1. Okay, so this way you can write any of the trigonometric function in terms of any other trigonometric ratio. So tan theta is opposite side divided, that will be opposite side is sine theta divided by root over 1 minus sine square theta. So this way you can write all.